Okay, so as we go over gas, before we go over gas stoichiometry, I just want to go over some information that we've learned in previous lessons. And so we're just going to review that today. So we learned about these resources, and you've seen this in the last video. So we're just going to talk about them. So as we do T-charts or dimensional analysis, there are a few conversion factors that I want to go over. The first one is when you are switching. It's called the switch. And the switch is when you use the coefficients from a balanced equation to change from one substance to another. Okay? And that's when you're going to have however many moles of one substance over however many moles of another substance. And this is when you're going to be switching from one to another. Then, if the question is asking you for particles, or you have atoms or formula units or molecules, then you're going to use this conversion, which we've already seen. And then same thing with grams. If the question is asking us for mass, you're going to find the mass on the periodic table and add them up if it's a compound. And then the one we're going to focus on today, and that's why it's highlighted, is liters. Okay, so today is gas stoichiometry. And at STP stands for standard temperature and pressure. And standard temperature is 0 degrees and standard pressure is 1 atmosphere. We'll learn more about that next unit. But at STP, 1 mole of gas is always going to be 22.4 liters. And that's going to be the number and the equation and the stuff we're going to focus on today. So let's move on to our first practice problem. All right. So just as we go, all of this problem, we're going to be, this is my chart. When I go from moles to grams, I'm going to use the periodic table. When I go from moles to particles, I'll use Avogadro's number. And the one we're going to be focusing on today is going to be going from moles to liters. So let's look at our first question. How many liters of oxygen gas would be required to produce 2 moles of carbon dioxide at STP? So the first thing that we're going to do is we are going to draw our T-chart, okay? And so I just draw my line, and then this is going to be more than one step, so I'm going to make my line pretty long. And then right here, I'm in my question, I'm just going to circle the information that I need. So I'm trying to get to liters of oxygen gas, and I'm starting with moles of carbon dioxide. Just as a reminder, oxygen gas is O2 and carbon dioxide is CO2. Okay, so the question is asking us for liters, and liters is a capital L of O2. So that's what we want to end with. That's the unit we're going to want to end with. So let's start from the beginning. We're going to start out with 2 moles of CO2. Okay, then we're going to draw our line. And the first thing we're going to do is we're going to take this unit and we're going to bring it down. We're going to bring it down here. And now we have moles of CO2 at the top. But we're at CO2 and we want to get to oxygen. So we are now going to convert from moles of CO2 to moles of oxygen. So we're going to have moles of oxygen at the top. Okay. And now we're going to look and we're going to say, okay, so to go from moles to moles, we use our balanced equation. We use the coefficients, and that's called the switch. So when you switch from one compound or element to another, you're going to use the coefficients. And so this is going to be where we switch. And I'm just going to write the switch so we know what we're talking about. And so CO2's coefficient is 2. So I'm going to put a 2 here. And then oxygen's coefficient is a 1. So I'm going to put a 1 here. Okay. And then I'm going to look at my unit here. And I'm going to look and I'm going to be like, okay, my unit at the top is moles of oxygen. But the question is asking us for liters of oxygen. So we're not done yet. So I need to do another conversion. And so I have to think, okay, I need to get from moles, I want to get from moles to liters. So in order to do that, I'm going to use my conversion factor from moles to liters, which is that 1 mole equals 22.4 liters. So I'm going to take this, I'm going to take my units here. I have moles of oxygen, and I'm going to bring them down, and I'm going to have moles of oxygen. And I want to get to liters of oxygen. So I'm going to have liters of oxygen up here. Okay. And then I have 1 mole equals 22.4 liters. Okay. 1 mole equals 22.4 liters. Okay. Okay, so I'm going to show you how to put this into your calculator. I don't have my TI-84 calculator with me, but this is an app on the iPhone called Calculator X84, and it works really well and actually is very, very similar to an TI-84. Most of the buttons are the same. So we're going to come here and we're going to multiply everything on the top and then divide by everything on the bottom. So what that's going to look like is it's going to be 2.00 times 1 times 22.4. And then, like I said, I divide by everything on the bottom. And so how I put that into my calculator is I do divided by 2 and divided by 1. I divide by everything on the bottom. And then I press enter. And then I end up with my answer right here, 22.4. And so that is going to be our answer here for our thing, okay? So now we're going to move on to our second practice problem. Okay, so for our second practice problem, let's read through the question. So it says, how many liters of NH3 would be produced if 70 liters of hydrogen reacted with excess nitrogen? So we're starting with liters of NH3, and we are given is 70 liters of hydrogen. 70 liters of hydrogen. So we are going to get started with our T chart. We're going to come here. And like I said, I draw my line pretty long because it's going to be multiple steps. And then I'm going to bring my 70 liters here, and I'm going to bring this down. And so it's going to be 70 liters of hydrogen. Okay. And so now I'm starting with hydrogen and I'm trying to get to NH3. And in order to do that, in order to do my switch, which is this guy right here, my units have to be in moles. So in order to do the switch, which I'm going to write right here, so to switch from NH3 to hydrogen, I have to be in moles. And right now I'm in liters. So I'm going to have to convert from liters to moles. So I'm going from liters to moles right now. So what I'm going to do is I'm going to take my units, liters of hydrogen, and I'm going to bring them down. And right now, I'm still at liters of hydrogen. But now, in order to switch, I need to be at moles of hydrogen. So I'm going to put moles of hydrogen at the top. And then I need to think about my numbers. So for liters, 22.4 liters is 1 mole of hydrogen. Okay. And now I'm at moles. And now I want to make the switch. I want to make the switch. Remember, the switch is when I go from hydrogen to NH3. So I'm going to take my my H2, my hydrogen, I'm going to bring it down. So down here I have moles of hydrogen. And I want to convert, I want to go to moles of NH3. So that's going to be my unit up at the top. Okay. Now I have moles of NH3. And so whenever I'm doing the switch, I'm going to take the coefficients, which are these numbers in front, from each element. So for hydrogen, my coefficient is 3. And then for ammonium or NH3, my coefficient is 2. Okay. Now I'm at moles of NH3. But if we look at our question, we're like, okay, what is the question asking for? The question is asking us for liters of NH3. And we're not there yet. We're at moles of NH3. So my last step is going to be, okay, I'm converting from moles of NH3 to liters of NH3. So what I'm going to do is I'm going to take my NH3, I'm going to bring it down. And so I have moles of NH3 here. And I want to convert from moles of NH3 to liters of NH3. And so in order to do that, I'm going from moles to liters. And so 1 mole equals 22.4 liters. Okay, now we're going to multiply everything on the top and divide by everything on the bottom. So we're going to be here, and we're going to do 70.0 times 1 times 2 times 22.4. And then I'm going to divide that by everything on the bottom. 22.4 divided by 3 divided by 1. And if you notice, I multiplied everything on the top and I divided by everything on the bottom. I press enter. I end up with 46.6 repeating. Okay. And so I'm going to go and round this. I'm going to round this to 2 decimal places. So our thing was 46.6666. And so I'm going to round this to the second decimal place. And so I look over, this 6 is going to become a 7. So I'm going to have 46.67 liters of NH3. And that is my final answer. Okay. If you have any questions, feel free to go and ask your teacher or come to a Zoom meeting.